be helpful. We had a lot of material for this class to watch online. I think there were 5 low-impact design lectures. I don't know how much time it takes to watch all of those. Probably some of you are like, way too much. But I'd like to just kind of debrief on the lectures themselves. We are going to go over various parts or the critical elements later today about sizing, rain gardens, and permeable pavements. But there's a lot of material that is covered in the lectures that we won't be talking about. So we're not going through in this class. We wouldn't have time without adding probably 2 more classes to cover each and every one of those practices in detail. And then there's a number of practices, such as the ones like wet ponds, artificial wetlands, that are typically might be more interest to you, that I don't even touch on in the lecture, because not having done them, my expertise is lacking. But going through the lectures, what questions do you folks have or comments? Yeah.
I think there were a couple of elements that, for a complete newbie in the lectures, were sort of assumed that we would know what they were, how they worked. So
Engineers are especially bad about that.
So for me, the under drain still was a mysterious element.
Oh, okay, yeah.
So where does it go?
Feel like, is it related to underdog? Or yeah.
I mean, I understood there was a pipe down there, but it was never explained.
Okay.
Does it connect to something? Does it just go into the soil? I didn't.
No, that's a great question. And without having asked, you would have had to just learn it on the streets. So let's talk about the under drain. I think I can turn this guy off. That was so good. Thank you so much, Adele. I owe you money now, I think. All right. So the under drain is essentially our backup drain for any low-impact design system that is designed to hold water that is on soils that don't allow it to soak in. So if this is our soil level, and we've dug it out to put something nice and green in here. So this could be a rain garden where we're ponding water, could be permeable pavement, it doesn't really matter. If you think about it, we've dug this hole in the dirt. And if your soils are really, really, really bad, so you've gone out there and you've done your infiltration test, you're out there in an urban area, or you're just in an area with bad soils. I'm working on a project right now near me that's in an area of soapstone quarry, so you dig down 2 feet and you hit bedrock. 0.000 infiltration. It's not going to go anywhere. So if you just dug a hole and you're catching rainwater in it, you've basically got a bathtub, right? That water has no opportunity to soak in, or it's going to soak in really, really slow. So what happens, the failure that would cause, that would pretty much cause a failure of any of the BMPs we talk about. Actually, for a wetland type feature, that's something you want, but that's beyond this class. So we need to make sure that this will drain down eventually, and by eventually, typically 48 hours is the magic number. Sometimes you'll hear 72. Part of that is driven by aesthetics. So if it's a rain garden, it's out in the middle of somebody's lawn, and it's still wet 2 or 3 days later, people can be upset. If you didn't pick your plants correctly, knowing that this is going to be wet for quite a while, it's not going to drain right down, then you might have problems, and you probably know better about the plant, but you might have problems with certain plants that aren't happy being that wet for that long, so you could kill your plants off. So you can create issues. Mosquito larvae is another big issue that'll come. I don't know what the incubation period is. We'll all know it by heart with Zika here before long. But anyway, you've got a bathtub here. You've got to give it a way to drain out. Pretty much all of these features at some level, we may have permeable pavement up here, we may have bioretention mix, doesn't really matter. At some level, we've got gravel, what we call an open graded, and that's another engineering term, open graded gravel. So open graded gravel is just stones that are all of a similar enough size, and you don't have fines in there. There's no sand, no dirt in there, so water will flow through it. Closed graded means it can be compacted like concrete, and it's got a lot of fines, it's got a variety of different grain sizes, and water won't flow through it. So open graded stone, and we'll come in here and we'll put our wonderful under drain pipe, and that is just typically, I would say 99.99% of the time, or 100% of the time if it's my designs, because I've never used anything else. That's my snazzy CAD detail for the end of the pipe. We will put a 4-inch diameter, usually PVC pipe. You can use slotted HDPE, but usually it's a Schedule 40 PVC pipe. And it's got little 1/4-inch holes drilled along the whole length of that pipe, and it's set in a gravel bed. The reason for that pipe is let's say this is a rain garden. Actually, if I can let that in there. It's a rain garden, it rains. At the end of the rainfall, it's all filled right up tippity top with water, right? That water slowly drains through the bioretention soil, and we've talked about the soils, and we did the little demo the first day. Goes through the soils relatively slowly. So if you're watching, the water's going in there, it will fill up. If it hits that rain garden, just disappears into the rain garden, and it's raining very hard, you probably got some bioretention soil that's a little bit on the sandy side, a little too much, it shouldn't shoot through it. I think between 1 inch and 8 inches per hour is the range for these bioretention mixes. So it's not going through it really fast, but relatively quickly. It goes into this gravel bed, and we'll fill up the gravel bed until it gets to the point that it gets to this under drain. At that point, it goes into these little holes, and it drains out. And so,
I get all of that.
okay.
And I assume that in something like the roadside bioretentions, that it's draining out to the street and just joining the flow to the sewers. But what about in
So your question is more
Where
this.
does that, where does that go? Where does that go? Particularly, I'm from the Woodland, particularly if we're
Sure.
doing a rain garden out in the middle of 40 acres.
Right. Well, it's
You're
from what I
sending
remember
it-
from your perk test, you probably don't need an under drain, but if you need one,
Right, but if you're sending it right out into soil that's not amended, why would that help you?
right, well, yeah, that's a great question. So I'm sorry, and just stop me and just say, no, shut up, quick, don't explain to us, the English alphabet. We just want to know. Yeah. Okay. So the question is, what happens at the under drain? And unfortunately, it's not a clear-cut answer. It depends. You need to get that out to an area of adequate drainage. So maybe your slope, and this is often the case, you've got a rain garden, and your slope goes down a hill that way. And so in that case, we run our under drain pipe out to daylight. Depending on the conditions, what does it look like out here? Maybe we put a little gravel area, maybe we put a splash box, maybe we put some check dams to slow it down. And it depends on how much flow you've got. Another question that I kind of heard inferred in there, and I've heard asked before, is if I'm just going down into a pit that's not got infiltration, and then it's running out the pipe, why did I spend all that money on special soils and plants? I mean, yeah, maybe the plants are nice, but who cares? It was a waste of money. But what I have found is a couple of things. One is you have a significant delay. So this water that's up here, it might take it, hours. What did you just drink? I want to avoid that. Oh, sorry about that. It might take hours and hours before you actually saw any water coming out here, so you've delayed that peak runoff, which helps the impact on the storm. The other thing that's very interesting is even if you have any infiltration, even if it's really crappy infiltration in here, it's amazing. Most of these storms are not real gully washers. They're fairly small storms. That water that used to run all the way down this slope will get in the rain garden, it will fill it up, and you'll never see anything come out the end of the pipe because it's slowed down enough and the infiltration is able to handle that. The other thing that they found, and this is more than you want to know, but I'm an engineer, can't resist, is NC State did research and they found that if you put this area down here, where you've got the gravel below. You might wonder, why don't you put the pipe on the bottom? And that's what civil engineers, that's what we used to do. We were, drain it, don't let any, no ponding water, so you have to drain it. But they found that if you have a sump, an area of gravel beneath this, even if you have no drainage below that, even if it's literally a concrete box, the water, when you think about it, it rains, stops raining, whatever excess flowed out here, but now water is essentially just sitting right below that pipe in this sump. It's not hurting anything, right? It's sitting down there, mosquitoes can't get to it, it's in the gravel. The next rainstorm comes in and pushes, that water kind of gets pushed out first, and they found that it's actually through the process of biology that's going on there, sort of like with a septic tank, you get nitrification and denitrification. You actually get reduced nitrogen levels coming out of that pipe as a result of having this drainage sump. So
you don't put the gravel underneath.
no, it is, all of this is gravel. The sump is completely gravel.
Okay.
So in reality, you dig your pit, you put your double wash number 57 stone in up to here, you lay your pipe in there, you top it off, you put a little choker level layer so your bioretention mix doesn't wash out the pipe,
Right.
then you put your rain garden mix in.
And
So
you
it's
said
all gravel.
what, denitrification?
Yeah, and you don't have to worry about that. That's just me being a
Well,
geek.
good to understand.
But you get additional storm, you get basically treatment and further reduction of the pollutants that were really the reason we put this in the first place.
Well, also just gravity, you're storing more, you wouldn't be
Yeah.
storing more otherwise because gravity.
Right.
to the bottom.
So yeah, because of that, you're going to have, it's going to further delay and reduce the amount that runs out here. And the bigger that sump is, the bigger that effect will be.
Do you put the holes in the entire length of the pipe or only?
Only through here.
And then the rest?
Right, because the rest is buried in dirt, and you don't want a bunch of dirt clogging up your pipe and